Hi, I'm Cameron Kello, Principal Scientist at Toughnano, Inc. Our presentation today is Journey Towards a Crystalline 3D Printing Resin, How to Work on a Shoestring Budget Without Tripping in the Now Laceless Shoes. Toughnano is a private research and development lab focusing on 3D printing resins and applications of nanomaterials. So our goal in this research was to produce a polyhydroxyethyramine 3D printing resin. This is a high toughness resin with a melting point around 210 C and a somewhat lower glass transition. This is in the sweet spot for the hardware on fused deposition modeling type 3D printing machines. We have produced lab samples of this resin and verified that it would be good for 3D printing durable objects. It also appears to have many other applications. So, while making this resin, we learned and built quite a bit. We found out how to make lab equipment on a shoestring budget. We developed modeling software for simulating complex chemical reactions, and we used our model to develop a specialized phase transfer process for high-yield production of N=0 diglycidyl ethers. Of the equipment we built on the journey, our favorite is this miniature injection molder. It has 4 temperature control zones in order to allow precise temperature control of the resin as it's being molded into test bars. One of the most interesting things to come of our work was a simulation of the reaction for producing diglycidyl ether of hydroquinone. We started with about 100 lab results, which defied interpretation on their own. But as we looked at them and the simulation, we were able to figure out what various factors meant that weren't obvious from looking at the raw results alone. Eventually, the simulation grew to process 94 differential equations in 54 variables and proved very helpful in developing a process for the production of diglycidyl ether of hydroquinone. So, our process for producing diglycidyl ether of hydroquinone is distillation-free. It yields the N=0 material in a very high yield, and it produces very few byproducts. We think that this process will be very applicable industrially. We want to thank you for listening to our presentation this morning, and if you want to see the full presentation, feel free to go to the ACS website. We're also glad to speak to anyone who visits us at toughnano.com. We are interested in research collaborators and potential funding sources. Thank you very much.